Look up. The sky is intensely blue. But why blue? If nobody painted it, where does that color come from? And what happens to all that blue at the end of the day, when the entire sky shifts to orange and red? The color comes from the sunlight itself. To our eyes, that light looks like a perfectly plain white glow. This animated diagram shows what happens when that white light hits a prism. It splits apart. That white beam is actually composed of every color of the rainbow, all blended into a single stream. So the colors are always there. Every sunbeam hitting the atmosphere already carries the blue that colors the sky. To see how those colors behave, we have to shrink down. Let's zoom into a single beam of light on a microscopic scale. This line shows how light moves in wiggly lines we call waves. Red light is made of waves that are large, stretched out, and slow. Now look at the blue wave. Blue light is made of tiny, compressed waves bouncing incredibly fast. The exact size and speed of those waves determines how each color travels through the sky. Think of the air above us as a giant obstacle course. It is packed with invisible, microscopic air bits. Those large, slow red waves are so long that they just step right over these tiny air particles without hitting them. This diagram shows the difference for the blue waves. Because they are so small and frantic, the blue light crashes directly into the air particles and ricochets off. When light bounces and spreads out in all directions like this, we call it scattering. Because blue light scatters the most, those bouncing waves are redirected toward your eyes from every angle. That is why the whole sky appears blue. Let's test what we've learned. Shout out the answers. How many colors in white sunlight? All of them. Which color bounces the most? Blue. What is that bouncing called? Scattering. You've got it. Scattered blue waves are the reason the daytime sky is blue. But if the sky scatters blue, why do sunsets appear orange and red? When the sun is low, its light travels a much longer distance through the air. Over this distance, bouncy blue waves hit so many particles they scatter into space. Only the slow red and orange waves survive the journey to your eyes. A sunset is the result of sunlight traveling so far that the blue has been completely filtered out. Let's recap the mission. Sunlight holds every color. Blue waves are tiny and bouncy, and the air scatters blue everywhere. You can see this happen right on your table. Fill a clear glass with water, stir in a tiny drop of milk, and shine a flashlight through it in a dark room. Look at the glass from the side. The milk particles scatter light like the air does, making the water glow slightly blue. But if you look straight through the water into the light, it looks orange. You've scattered the blue away, creating a sunset in a glass. Now that you understand the blue sky, what about when it rains? Why do giant arcs of color appear once the storm passes? Tap right here to find out how rainbows work.